Beneath this video, there is a link to the brief for this project, okay? And we're going to go straight there now. We're going to, guys, I feel like I should tell you about this. This is a great to-do program. It's called habitica.com. If you want to have that RuneScape, old school RuneScape style to-do list thing, check it out. That was random. There you go. So have a look at that. So below is this link, and I want you to click on it, and it will obviously take you to my GitHub, and you will find this GitHub repository. First thing I want you to do is I want you to click this. So it is a watch, so you can see any updates that I make to this, anything that's added. You never know where something that I type or write might give you that aha moment. And let's star it as well. Okay, so I want you to star it as well. It'll just help other people who come here to know that this is legit. So your star will help other people who click on here to see that this is not garbage. So this is where it starts, guys. Okay, this is where you will now break away from that tutorial hell that you've been stuck in, and you're now going to build a project on your own with me discussing as much detail about the project to help you through. Okay, so once you come in, there's a little brief about, why this is your first ever project. It says in the coming weeks, but some of you might be so good at this, or you might find it easy enough that you could probably do it in a week, maybe even less. The thing that makes this take a week maybe is that we're not just coding. So we have to dissect the brief to start with. We need to see what we need to do. We need to then code this, and then afterwards we're going to make documentation for our code so that anybody who comes along to look at it can then understand what your code is about. So, and sometimes documentation can take a while. Sometimes it can take longer than coding because some of us are really good at coding but then terrible at writing or being able to express ourselves in text. And that's okay. If your documentation takes a while, it's fine. It just means that you're actually putting in the effort. So, table of contents here. So I've made this more to show you when we get to documentation how when your repository is on private, how you can manually make a wiki. So the reason we're making a wiki is just to tick the box so that it's a skill set that you have learned and that you can use in the future. It's not really necessary for this, but I've done it anyway. So you can hear there's a whole bunch of things. So I've broken down every single method in the class that you will be doing. And at the bottom here, there are test cases for you to check to see if your code has error handling in it. So let's not worry about that now. There are plenty of videos on this. Let's go into project instructions. You have been assigned the task of completing a car simulator for a design strategy firm. The previous employee has written some of the boilerplate code, and you are asked to continue to implement the sim using this code. Copy it to your Pi file. So that's really important that if you're taking bullet points or anything like that, we need to find the boilerplate code somewhere in this file so that we can copy it into our Python file. But let's keep reading first. The sim will request commands from a text file located in your project. Please create a text file named simulation.txt next to your Pi file and copy the commands into simulation.txt. Okay, so we now also have to take text from somewhere and place it into a file. Okay, so here we have a very generalized left and right of field, our arcs of fire. The car must follow these principles. Accelerate will speed the car up by 5. That should be kilometers an hour. Okay, so I'll put that in. Okay, brake will slow the car down by -5 kilometers an hour, or miles, wherever you're from. Forward places the car in D or drive. So this is an automatic car. Reverse places the car in R or reverse. Right turns the car clockwise. Now that gives us a hint about something that we might need to learn about a little bit later. And then left turns the car anti-clockwise. So it looks like we've got a little bit more in-depth look at reverse here. Braking parameters. The car will -5 when braking in forward and +5 when braking to reverse. Okay, so it seems like programmatically, this is asking us to, when we accelerate, we need to move away from 0. So +5, we're moving away from 0. And obviously 0 represents the car is stopped. And then reverse, -5 because it moves away from 0 in the opposite direction. Okay, that makes sense. Okay, the car cannot brake past 0 regardless of the commands given after it reaches 0. So basically, I guess what that's saying is that if somebody just copy pastes a whole bunch of accelerates and then doubles that number of brakes. So let's say we have accelerate, accelerate, accelerate. So that'll go 5, 10, 15, 20. And then somebody puts in, sorry, I'm trying to make sure my thumb is on screen. And then it puts in this many brakes. So that's, we're accelerating at 20. So that's 20, 15, 40, 15, 10, 5, 0, -5. But the thing is though, is if the car is in D, the car can't go into reverse. So which means that when we have the command to brake a second time, if we step on the brake and the car is stopped, there is no change in speed. So the car will remain at 0. And you can see here, it kind of gives us a little bit of a hint where it has a statement that we could use. We could print this statement to the user and say, this car is already stopped. Please stop braking, you know? Okay, accelerating parameters. The car will +5 when accelerating in forward and -5 when accelerating in reverse. So again, it's moving away from 0. The car's top speed is 80 kilometers an hour and 15 kilometers in reverse, which is -15, okay, -15. Like a real car, the sim must be at 0 kilometers an hour to safely change from D to R. So those of you who have never driven an auto car, which is quite common in Europe, so in Europe, it's quite common not to drive automatic cars. So if you are European or you're Indian, Bangladeshi, or anything like that, Sri Lankan, and you don't know about automatic cars, because I didn't until I went to Australia. So you can't click the car into reverse while the car is in forward motion, because it will ruin the car. Okay, so you must stop, okay, and then click it into reverse or click it into drive. So the car must be stopped. And that's what that's saying is, please let us actually simulate this like a real car. So if somebody does do that, okay, we just have to brake the car. So what happens then is, if the car is traveling at 20 kilometers an hour and then there is a reverse command, what we do then is we just brake the car. So boom, the car is broken. Okay, so this is just a programming problem that we want you to show that you can solve. So don't stress about it, but this is something we want you to show that you can solve as a programmer. Okay, gear changing parameters. So the sim must change gear for the user. So again, like I was saying, this is an automatic car. The user does not change gear. We change gear, which means that as we go up in speeds, we must check to the speed and see what gear the car must be in for that change. We now have the gear ratios just here. So you can see here, 0 to 10 is first, 10 to 20 is second, 20 to 30, 40 to 30 to 40 is fourth, and then 45 and above is fifth. Okay? I don't even know if that's a good gear ratio. That's just what I made up, so bear with me. Don't pressure yourself to have perfect ratioed gears. Just focus on them changing close to the desired speed. So basically what that means is if you go from 1 to 10, and that's first gear, but then if you notice here, it says from 10 to 20 is second gear, okay? So maybe in your sim, so that programmatically, like you're not destroying your brain trying to figure this out, maybe that's 15 to 20. And then this one says, 20 to 30, but then this is 20. So maybe this one is 25 to 30. Do not destroy yourself with my gear ratios here. Like, if you feel more comfortable with a separated numbering system, do it, okay? Because we're not here to deal with this. This is something you can come back in the months later when you understand logic and problem solving more. You can come back and fix this later. Don't worry about it. Focus on completing the coding so that we can get on to documentation, and then you can say then that you have completed your own project. Okay, do not die on this hill. Please do not die on this hill. Nothing has to be perfect. Do not destroy yourself for months trying to figure out how to make this project perfect. I am not interested in you making a perfect project. I want you to complete this project from start to finish as best as you can. Anyway, I'm sorry about my rant. Okay, so this part is a little bit important. Okay, this is important. So as this is a console-based project, which means that it's going to print out like this. Okay, and you can see here it says direction equals 12. This is a console-based project for beginners. So to be able to display the direction of travel, we're depicting a clock. You can see here, this is a clock. Okay, the car starts, so when the simulation starts, the car is at 12 o'clock. Again, that's something you have to figure out. Okay, again, don't overcomplicate it. If it has to be a little bit hacky for you to make sure that the car displays 12 at the first printout, so be it. But you figure that out. If it turns left, okay, it goes to 11 o'clock. If it turns right, it goes to 1 o'clock. Okay, but I discussed this in a video. Find that video if this doesn't make sense to you and watch that video. It will help you to understand this particular part, because it can be a little bit tricky. If you're really delving into like this problem, your mind is fixating on this problem a little bit, you're trying to figure out where these commands are coming from. Maybe your brain just died when I told you this. Don't stress, okay? Don't stress. There is videos to come that will really help you to understand this concept. So don't stress. Some of you are like, what the hell is he on about? I know exactly what's going on. Some of you won't. Some of you are going to be so spatially aware. You're going to be so amazing at spatial concepts that when you have text concepts like this, your brain just implodes, and that's okay. I'm one of those people too. I don't get text. Give me a video, because I can't read and understand things. Okay, this is the console output because it is a text-based console program for beginners. So this is what it will look like. And again, this is spoken about the whole way through the videos that are to come. This is the code that the employee left behind, and you must use it. When you start out, do not make changes. You don't need to delete or change anything in this. You can build this program with this without changing any. You shouldn't be adding extra arguments to any of this. you know, you shouldn't change this default argument. Don't change it. You have to learn how to be able to work within these parameters. What you can do though is maybe if you want to like have a max speed variable here in your globals, no problems. Maybe you want to add a minimum speed, no problems. Whatever, you can add little things like that. Maybe you're a little bit more advanced and you want to move all your error handling to another class. Absolutely. And then of course you'll have self dot and you will add your object in here. Again, speaking to people who are a little bit more advanced, if you don't understand that, absolutely ignore what I said, okay? These are the commands, okay? They're not rigid, so if you copy and paste this in, you don't have to keep this exact command structure. You can fiddle around and change it. And I even have, if I just go back, we have test case down here, and these test cases, which is just a computer science way, a software engineer way of saying you can paste this in to test for these things. So, for example, top speed. Now, like I said, the top speed of this car is 80 kilometers an hour, which means that you need to have an error handling in there that will stop it from going to 85. Okay? It's just an if statement. It's just an if statement. I didn't tell you that, okay? And what this does is this pumps your speed all the way up to like 85, 90 to see if it does go over. If it does go over, that is incorrect. You need to put in something, and this then returns the car to 0 speed. Okay? It's just there so you can watch your simulator run. Here's another one, top speed in reverse. So the top speed in reverse is minus 15 or 15 kilometers an hour in reverse. It's minus 15. Clockwise and anti-clockwise. This is here to make sure that you have made a clock simulation. Again, the video will explain that, okay? And this will just break the car. So what it will do is it will accelerate forward and then just slam the car in reverse to make sure that your car is broken. See, here's a great example of what you might tell the user. Boom, the car is broken. The car is already stopped. Okay, sorry, this is it obviously in reverse. So this is going forward and breaking the car. This is going in reverse and breaking the car. So this one checks to make sure that if you try to keep braking, the car will not go into negative numbers while in forward. So you can see here it's placed in forward. We accelerate twice, which means it's going 10 kilometers an hour, and then we brake a whole bunch of times. And what we want is we want to have something like, hey, the car is already stopped. The car is already, the car is already stopped. Okay, so I've already mentioned this. Oh, look, there's an example of the car is broken. You can see here, there's an output here saying the car has been placed in reverse. This is what you'll be expected to print out for the user so the user can see where they are. You can see here that we tell the user that we are changing gear. So it's important to let the user know what is happening behind the code. And then turning, there's another one, accelerating. So you can see a pattern here of things that might need to be placed inside some of your methods or functions, methods. Yep, we've already mentioned this. So again, you can copy it by clicking this button, see copy, and then you can paste that inside your Py file. Just in case my explanation, maybe you're someone who can't necessarily like extrapolate the instructions from what I'm talking about, or maybe this code. I'm going to show you now, okay? So let's just let's open Visual Studio. Maybe it's got some of the things I've been working on. Apologies for my crazy ass orange background. Okay, so this is, let's go open recent. Okay, carsim.py. So just so you can see what I mean by that, you can actually see it's right here. And I've been writing some crazy code. That's not code, guys. That's just me showing you what to do. Let's go here, go delete. Okay. Go S. And yep, so we'll start here. Okay, so this is what we want to do. I want to go in here, and while we're reading this, we'll see you have assigned the task of completing a car sim, blah, 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 blah. And then we come to this, and we're like, okay, so we need to find this boilerplate code. So we click here, and it will jump down to the boilerplate code. And then we are going to copy the boilerplate code into our IDE or editor. So if you use PyCharm, anything like that, this is what you're going to do. What I'm going to ask you to do is don't do this yet because you are going to want to make a GitHub repository for this and place it in. And if you don't know how to do that, I want you to jump into the next video or one of the videos coming up and learn how to be able to do that. So what to do is make this in a GitHub repository so that it can be placed up onto GitHub in the cloud. And I talk about why this is important in the GitHub video that I talked to you about. So I'm not teaching you how to open a GitHub account here. I'm teaching you why you need to use cloud-based products to be able to present your code. So what we're going to do now is, now this is obviously inside your GitHub account, which you understand about now because you watch more videos, but we'll go here, Control V, okay, and we paste in our code. And I said, you'll hear me talk about this many, many times, but you can see here that my indentation is incorrect. I talk about that in one of the videos and then we correct it. So I'm going to let you go through the videos and learn about that. If you are proficient, you know what to do here. You know it's just about fixing the tabs. Do it. Okay. So we have our boilerplate code inside our project. And the next thing that we want to do is we want to go new file, and then we want to go simulation. I believe it's simulation.txt. I expect you to check that. Make sure that's right. Make sure it's spelled correctly. Simulation.txt. Yes. Okay, and it's a text file. And then what we want to do is, so that we can just start running our code immediately, is that we want to add maybe just these commands. Again, if you're not happy with these commands, go back. Let's go back again. Okay, and this is the README file, the original with the table of contents, and you can go down to test case, and you can just pick something that you maybe is more relevant to you starting. However, if you don't know where to start, go straight back to instructions, go below the boilerplate code, copy this, and then in simulation.txt, you just want to Control V and copy them in. And you can do the same with those test case, but maybe you just want to make sure that every single one of these commands is covered. You can easily just have like forward, accelerate, right, get rid of that. Add left, get rid of that. And then get rid of all these breaks. And I believe the last one we need this. Okay, 1, 2, 3, 4, 5, 6. There we go. They are the 6 commands that you'll be using. You are more than welcome to just start with that. Okay? And that's it. This is you at your starting point. So you have your boilerplate code, you have your simulation.txt. You need to make sure that they are sitting next to each other in your project. And now you are ready to start. So from here, you want to go and watch some more of these videos to make sure that everything that you need is covered. If you know how to do this, maybe watching the videos that discuss the methods in depth is something that you don't need to watch. But one thing I will ask you to do if you don't know about GitHub is to watch the GitHub videos so that you are at least creating your project inside your repository, which is really important. because you need your the README file to be able to create documentation. Get down in the comments if there's anything that you're not sure of, but just remember that a lot of your questions will be answered in the videos to come. The comments are there for you to shake out any worries that you might have, because you are probably for the first time building a project without following somebody coding. You are not going to find a bouncing ball here. You will be writing all the syntax yourself. You'll be testing all your code yourself. You'll be expected to deal with your bugs and any problems you have with your code yourself. Good luck.